Hi everyone, my name is Rachel Doring, and here is the results and processes for the Lab 1 on charged tapes. The overall purpose of the lab was to determine an approximation for the excess charge left on a piece of clear tape. The experiment showed how everyday items can be influenced by the transfer of charge and to create a better visual reference frame. To do this, we placed two pieces of tape on top of one another and quickly ripped them apart. This gave the tape a charge. We created two identical pieces of charged tapes and placed them a certain distance apart so that one could hover above the other. Since the two U tapes were made the same way, I expected that they would have like charges and would repel one another. Some observations that I had regarding the tape was that it was attracted to my hand but repelled each other and other objects such as a TV. The U-tape was attracted to the negatively charged pen, indicating that the tape was positively charged. Some basic measurements that were recorded throughout the duration of the experiment were the tape's mass, the length, and the distance between the two tapes when they began to hover. The gravitation force was calculated by multiplying the mass times negative 9.8, which is equal to the magnitude of the electric force due to Newton's second law. This conclusion came from drawing a free body diagram for the top piece of U-tape and a net force equation that showed us the equal magnitudes of the forces. To calculate the charge on one piece of tape, I used Coulomb's law, which calculates the electric force between two charges. Since we already knew the magnitude of the force, we could easily solve for the charge of one piece of tape. Some assumptions that were made during the calculation was that the charge of the two U-tapes were equal due to their identical creation. And I also treated the charge on the tape as a point charge. Next, I calculated the total number of excess electrons on the tape by dividing the total charge, which was found on the previous slide, by the charge of a single electron to get a final answer of 4.4 times 10 to the 9th electrons. Finally, I calculated the total number of atoms on one side of tape by dividing the length of the tape by the diameter of a single atom, which then gave us a ratio of 2.16 electrons per atom on the tape. This number makes sense as the overall net charge of the tape was positive, so the number of electrons per atom on the tape should be relatively low. The next part of the lab was to create a computational model of the results using Python. I did so by first creating my constants, then plugging them into the correct equations to solve for each of the necessary values. Those values were then printed in the text section of the program. Then, by modeling the tape as a point charge, I was able to create a model of the force vectors acting on the U-tape. Creating the computational model allowed me to verify my calculations. The calculated value for the amount of charge needed to float one piece of tape on top of the other is 7.05 times 10 to the negative 10th coulombs. The total number of excess electrons on one piece of tape is 4.4 times 10 to the 9th electrons. And the total number of atoms on one piece of tape is 2.032 times 10 to the 9th atoms. If electrons had a positive charge and protons had a negative charge, the results of the lab would have been the same. The human labeling of the charges does not alter the effect that opposite charges attract and alike charges repel one another. Also, it is very important to be careful when handling the U-tape because the charge can be easily transferred by the tape to a hand or any surrounding object that it comes in contact with. In conclusion, the experiment allowed us to witness the effects that the charges have on one another and come into the realization that opposite charges attract while like charges repel one another. The two charged tapes came into equilibrium, which allowed one piece of tape to hover over the other. Then, from these measurements, we were able to calculate the charge that is on one piece of tape, along with the number of excess electrons and the number of atoms on one piece of tape.